So now we have seen everything that we need to know in order to understand what is decision tree. Let us also understand that how exactly we should implement decision tree algorithm. Okay. So everyone open your Jupyter notebook. So over here I'll create a new notebook and I'll name it as case study on decision tree. Okay. Case study on decision tree. I'll import the necessary modules first. From warnings, import, sorry, import warnings and warnings dot filter warnings, ignore, import numpy as np, import pandas as pd, import matplotlib dot pyplot as plt. And today we are going to use cbon as well. So sns dot, sorry, cbon as sns. So we'll be again using the same iris dataset, guys. And yesterday, I remember long ago, a particular student has asked me that how to load this iris dataset from sklearn itself. So let me teach you that as well. Okay. So guys, sklearn, TensorFlow, and there are certain libraries which has some inbuilt datasets. They provide you some amount of datasets. Okay. So we are going to use one of those datasets today. So from sklearn dot datasets, import load iris. Okay, load iris, and I'll create a variable called iris and I'll call load iris in that variable. Okay, I'll call load iris in this variable. Now iris has some attributes. Iris has something called as data attributes, which will give you the uh, entire data in the form of array. Iris has target attribute, which will give you the target variable. Again, 0 is represents setosa, iris setosa. 1 represents iris virginica, and 2 represents iris versicolor. Okay, this has already, let's say, has been encoded into numeric value from categorical data. Okay, also it has the column names. So iris dot feature, okay, feature underscore names, that will give you all the column names that it has. Okay, so initially, or you can say eventually, what we do is we have this iris dot data in our x, and we have iris dot, sorry, iris dot target in our y, but we are not going to do that. Okay, instead of that, what I'm going to do is I'll create the data set from this particular bunch of values. So in order to do that, I'll use pd dot data frame because I want to perform some eda on this. So iris dot data is the columns, and column names we are going to assign it as iris dot feature names, that is the column names. Okay, whatever it returns, I'll assign it to df, that is data frame variable. And then we have df head. So it gives me everything except the target. So I'll create a new column called class. I'll assign iris dot target over here. If you check your df head now, that will give you the target column as well. Okay, so now let us see the eda, that what exactly we can do on this particular data set and what insight we can draw from this. Okay, now this case study I'm going to create based on the project that we actually execute in the real life. Okay, आपका प्रोजेक्ट जो होगा इसी के हिसाब से एक्सपेक्टेड होगा आपसे. Alright, so we have, let's say, the shape. Okay, this attribute, and if you don't want to use the shape attribute, you can simply use df.info, which will tell you the number of rows and columns. Okay, there are 150 samples, 150 records, you can say, in the particular data. There are 5 columns in here. All the columns are numeric. Okay, except this class. This shows the numeric data type, but it is discrete continuous. It has certain categories in it. Okay, since we have encoded it, or you can say it is by default encoded by your sklearn, so it is giving you an integer value. Right. Apart from that, if you go ahead and check the describe method, right, so it has this sepal length column. Okay, if you see, the mean value is 5.8 and median is 5.8 only. ठीक है, दोनों equal है. Okay, but there is a little difference in here. 0.04 का difference है. So what we can say, this it is almost normally distributed, but yes, there is some amount of skewness in that. Okay, very little amount of skewness, but yes, it's a normally distributed data. But the problem here is, if you can see, the minimum is 4.3 and the maximum is 7.9. Okay, so there is a little variance in the data. The data is highly scattered, you can say, right? There will be some variance in it. I can say the range of the data is quite high, not variance, but range of the data is quite high. Also, if you see, this mean is 3 and over here the mean is also 3, so it is also normally distributed. Then petal length 3.7, petal length, if you check, the mean value is 3.7 and the median value is 4.3. We can come to the conclusion that it is a left side skewed because the median value is greater than mean value. Okay, so that is what we have in here by your descriptive statistics. Let us also check that what amount of records do we have in each category. Okay, so df dot group by class. I'll use size method here. So all the three classes, class 0, class 1 and class 2, which is basically Setosa, Virginica and Versicolor, has 50 records. Okay, so let's create a kind of a plotting here. चेक करते हैं ये जो सेपल लेंथ और सेपल विड्थ है एक कैसा रिलेशनशिप दिखाता है. So df dot plot kind would be scatter. We'll be creating a scatter plot because if you want to check the relationship, scatter plot is a good one. So in x-axis, at x-axis, we'll be having sepal length in centimeter. In y-axis, we'll have sepal width, okay, in centimeter, right? So df dot grid, I'll just have a grid here and plt dot show. So guys, if you can see here, it is very much clear that there is one class. I don't know what class is this. Okay, and there is this class. Okay, if I just use my marker, okay, there is one class over here and there is one class over here. Okay, there are three categories, but two of them can be linearly separable. Okay, यहाँ पे दो कैटेगरी linearly separable हैं. Okay, but यहाँ पे अगर आप ये चेक करो, ये बड़ा वाला कैटेगरी चेक करो, so there must be some data points which is overlapping on each other. Okay, because in my information there are three classes, but यहाँ पे cluster या group सिर्फ दो ही दिखाई दे रहा है. Okay, that is what we can draw into. I mean, we can take into consideration. Let's also check the pair plot, which will give the fine idea that what exactly is happening in the data. So sns dot set white grid, or you can say set style. Actually, will set white grid here. Okay, and sns dot pair plot data would be rdf. Will take into consideration of class column, right? The size would be 3. size of the graph, and the diagonal graph would be a KDE. Okay, we'll be using KDE plot over there. So plt dot show. Okay, so I was correct. As you can see here, there are two classes which can be easily separated. Okay, there are two different classes which can be easily separated. If you see this one, right, if you see this one, we can clearly separate this class from this class. Okay, we can easily separate this two class from here, but there are data points which are overlapping here. Okay, so the line would be something like this, right? Line would be something like this. So there are data points in one of the class which is overlapping on each other. We can easily separate two class. If you see here, the light color is 0, that is setosa. So we can easily separate setosa from other two categories, but there are points in versicolor and virginica which is overlapping on each other. All right, there are some points which is overlapping on each other, and this would be the perfect example of that. Okay, as said, we can easily separate the setosa class, but if you can see here, there are some data points which is overlapping on both the categories. Okay, that is the reason it is showing only two clusters. Okay, so now we have seen that there are certain some amount of skewness here in petal length 3.7 and 4.3. So let's check what amount of skewness do we have. So for skewness checking, we'll be naming. We'll have to use the names of all the columns. So call name. If you remember the EDA sections at the starting. So df dot actually, let's go step by step. So df dot select these types. Okay, we'll be selecting float 64. That will end up giving me this particular columns of all the float value. I'm not concerned about the data. I'm just concerned about the names, basically the column names. So these are the column names. I will save this in the variable called call name. Okay. I'll save this in a variable called call name. Okay. Now I'll import a library from scipy.stats called skew. So for column in df call name, for column in df call name, print call, print skew df call, that would be the each column in the column name, and we will also print, or you can say plot the figure. So plt dot figure, plt, sorry, not plt, sns dot displot df call, and plt dot show. This kind of graph will come to us. So almost all the graph, if you see, this is kind of a normal distribution. Some amount of skewness is there. I agree that. Okay, there's a little amount of skewness over here. Again, there is little amount of skewness over here in sepal width. Okay, okay. But if you see this petal length, there is many values here, which is, I mean, which has some different range. Okay, which has some different range. That is the reason it is going in the negative. So let us check the range as well. Okay, skewness होने के दो तरीके, I mean chances हो सकते हैं, या तो actually there are some difference between mean and median also. There can be some outliers, right? So if you plot a box plot, that will give the idea of both outliers and the range as well. So let us create the box plot, guys. I'll be using the same code. Okay, this one. I'll just create the box plot here by using the same code. Instead of skewness, I'll not call this skew. I'll print the column name. Actually, there's no need to print the column name as well. So let's remove that. And instead of dist plot, I'll use box plot, right? Instead of dist plot, I'll use box plot, and in here the data would be rdf. On x-axis keep the class, and on y-axis we'll have df call. Okay, that is an y-axis. We'll be also having grid in order to understand the range. If you see this, both the categories has different range. Okay, both the categories has different range. Setosa range from 4.4 to 6. Virginica range from 5 to 7, and versicolor has an outlier over here, and it ranges from 5.5 to kind of 7.8 or something. Okay, and then there is some outliers in sepal width column for virginica, sorry, setosa and versicolor. There is some outliers in setosa and virginica for petal length. Then there is some outliers in setosa for petal width. Okay, so this gives me the clear picture that what exactly the range of each column category wise, okay, or species wise. सेटोसा का क्या रेंज है, पेटल लेंथ का, पेटल विड्थ का, मुझे उससे पता चल जाएगा. सिमिलरली सेपल लेंथ, सेपल विड्थ, पेटल विड्थ, वर्जिनिका और वर्सी कलर का क्या रेंज है, मुझे इससे वो पता चल जाएगा. Okay, but again guys, if you have understood this decision tree, it selects feature by feature, right? In order to uh, segregate the classes purely, it selects the feature, okay, which is totally pure or which has less amount of impurity. So it selects features first, right? So feature selection defaults happens over here in decision tree. And when there is a feature selection which is automatically happening in decision tree, so there is no need to handle kind of a skewness or outlier in here. आपको skewness handle करने की जरूरत नहीं है, आपको outlier handle करने की जरूरत नहीं है, because here in decision tree feature selection is by default happening, so there is no need to handle. I'm not going to remove any kind of skewness or outliers from this particular data. Okay, so it is taken care by your algorithm itself. Apart from that, if you want to understand that what is exactly the depth, or you can say the range, or how varies your data, कितना percent data किस range में belong करता है, so we have something called as sns dot joint plot. Okay, so here the data would be df, x will be our petal length, centimeter, that is our x. Y will be our petal width, and I'll use kd. So if I run this, this will give you something like this. Okay, and this shows exactly that definitely, yes, we understand that there are three categories, but one of the categories overlapping on each other, and there are, let's say, one category which can be easily linearly separable. Okay, setosa को मैं linearly separable कर सकता हूँ. We can divide setosa class from rest others by easily creating a single line. Okay, but there are some data over here which is overlapping, that is virginica and versicolor has been overlapped on each other. Okay, so that is what the scenario is here. So this gives me the clear picture, ये जो मैं बस ऐसे ही guess कर रहा था यहाँ पे, so that gives me a clear idea that yes, there is a class which can be easily linearly separable, but there are few classes or few categories which is overlapping on each other. Right, and guys, if you want to check whether how good your setosa looks like, so setosa is your zero class, right? Class 0 is setosa. If you see here, setosa is your zero class. So what I'm going to do is I'll just filter out all the rows which belongs to the setosa. So df dot class equal 0. So this will give me the boolean values, and when I map this value or mask this value on my data frame, that will give me all the rows which has zero class, which belongs to zero class or which belongs to setosa. Okay. Now what I'm going to do is I'm just going to save this data in a variable called s. This data frame which has only setosa class in it, I'm going to save this data in a variable s. And sns dot joint plot. Okay, my data is s, right? X is your, let's say, petal length in centimeter, and y is your petal width in centimeter, and we'll be using again kind equals KDE. So this is how your setosa class looks like. This is how it is distributed. ये इसका distribution है, ऐसे spread है वो. Okay. And again, if you want to check for some other, let's say I want to check for versicolor, so instead of 0 I'll keep it as 2, and instead of s I'll name it as vs, that is for versicolor. So vs. If you want to check for petal length and petal width, this is how it looks like. Also, let me show you, or you can say introduce you, one of the cool plot called as KDE plot. One of my favorite, you can say that. Instead of joint plot, I'll use KDE plot. Okay, so I'll just remove these parameters. I'll just remove this parameter from here. So S, that is setosa, sepal length, or you can say sepal width in centimeter. S, that is setosa, sepal length in centimeter. Actually ये bracket यहाँ पे close नहीं हुआ, so sorry. Right. So this one is an extra bracket here. And I'll use something called as CMap. CMap parameter. So CMap would be plasma, right? CMap would be plasma. And apart from this CMap, guys, there is some more, let's say, parameters called as shade and shade lowest. Okay, shade and shade lowest. So we'll also use this shade parameter, shade as true, and shade underscore lowest equals false. If I run this is how it gives me. This is a plasma structure ki kitna kya scattered hai. So if you can see here, there is one kind of an outlier present over here which is outside that data. Let us check that whether this setosa has any outliers or not. So if you see here, sepal width, there is an outlier. Okay, in sepal width in setosa it has some outliers. And if you see this petal axis, we have mapped sepal length and sepal width. So in sepal width, it has two outliers for setosa, and sepal length don't have any outliers. So I guess this is showing about this sepal width only. So there is this outlier present over here in this particular plasma map. You can do the same thing for versicolor or virginica as well. All right. So if I just create one more KDE, okay, one more KDE for, let's say, virginica. So not this one, this one. Instead of joint plot, let me take KDE plot. uh, ADE plot, CMAP plasma. So this is one of the feature, and if you use the shade equals to when shade lowest falls, this will give you the exact same structure like this. Okay, so it is your choice that whether you want to use, or you can say use your KDE plot like this or with shaded. Totally your call. Now, what insight did we, I mean, got from this kind of EDA? So let's finish it. We can continue here further, but as you can see, the timing you have to execute on your own as well. So let's conclude it till here. That whatever we have learned. So point number one: the given data, okay, is of iris flower, which has 150 samples of three attributes, or you can say three different species, with four attributes, four of its attributes, that is sepal length, sepal width, petal length, petal width. That is first point. Point number two: most of the column is continuous in nature, except except class, which is discrete continuous. Right? Point number three: by observing by observing the descriptive statistics, okay, of the data, we can say that petal length petal length column has little variance in it, and rest every other column every other column is almost normally distributed. Okay, almost normally distributed. Point number four: uh, also, if you notice the median value kitna tha? Let's check. I don't remember. So descriptive statistics of median value is 4.3. Petal length ka median value 4.3 and mean value 3.7. So it has some amount of skewness, right? So the median value is 4.3. 4.3 is greater than mean, that is 3.7. We can say that petal length is left side skewed. And point number five is, this is a kind of a domain expertise. If you go ahead and read the research papers in that UCI website on iris, you will understand that petal length, okay, and petal width, okay, are the most useful attributes to identify, okay, most useful attributes to identify flower type. Okay. And lastly, being linearly separable, setosa can be easily identified. Whereas virginica and versicolor have some overlapping. Okay, have some overlapping. So these are the insights, guys. Now, I mean, I have stopped till here, but we can also mention about the different range that these species has. Okay, by using this particular diagram, by using this chart, we understood that each species has different range. Each column has different range. Okay, and few of them has some outliers as well. Okay, so we can also mention it over here. Okay, but these are the important things that we must write, right? So this is how you should create the case study. It's not at all about, let's say, loading the data and drawing some kind of plots or pair plots or descriptive statistics. You should also have the idea about insights that those plots are telling you. ओके, ये मैं शायद DWD के लेक्चर्स से कहते आ रहा हूँ आप सबको, दैट क्रिएटिंग द मॉडल और लेट्स से क्रिएटिंग सम प्लॉट इज नॉट दैट इम्पॉर्टेंट. इम्पॉर्टेंट क्या है, यू शुड बी एबल टू let's say narrate that what exactly those plots are telling you, what insights you are getting from those tables of info and descriptive statistics. Okay, that is what important is. Okay, you should have the knowledge of data storytelling, that given the graph, given the data in front of you in the form of graph or table, you should narrate a proper story out of it. Okay, so this is one of the important case study here that we have created, which will can say which is giving you a proper insight of how EDA can be performed. All right, we have not done anything new. This is this might be done in your AWB sections in Seaborn or let's say pandas plotting. Some of them we have covered in the DWD topic. I myself have taught you some topics in pandas plotting, value count, and all those things. But these SK learn is kind of advanced topics which might have done in AWP, whoever is taken. Okay, so this is the way you have to create your projects. Okay, this much of EDA with the proper insight that what exactly those tables, what exactly those graphs are telling you. After that, you have to continue with your model creation, a model evaluation, hyperparameter tuning, and all those things. Okay, is that clear till here, everyone? Guys, you have to make sure, guys. ज़्यादातर ऐसा होता है कि मशीन लर्निंग प्रैक्टिशनर्स को या फिर जो भी डेटा साइंस का इंटरव्यू देने जाता है, उनको एक्चुअली पता ही नहीं होता कि आपने अगर ये मॉडल क्रिएट किया है तो क्यों किया है, व्हाट इज द रीजन ऑफ क्रिएटिंग दैट मॉडल. अगर आपने ये ग्राफ क्रिएट किया है तो क्यों किया है, व्हाट इज द रीजन बिहाइंड दिस क्रिएशन ऑफ दिस ग्राफ. एग्जैक्टली पता क्या करना था आपको कि आपने ये ग्राफ क्रिएट किया. ओके, और जब ग्राफ क्रिएट हो गया तो एग्जैक्टली क्या बोल रहा है वो, you should know this. Okay, ये एक लेट्स से इम्पॉर्टेंट फैक्टर हो सकता है आपके इंटरव्यू क्लियरिंग या इंटरव्यू प्रिपरेशन में, कि आपको पता हो कि आप ग्राफ से क्या ढूंढ रहे हो और आपको ग्राफ बोल क्या रहा है. राइट, यहाँ तक अगर सबका क्लियर है, सो डू लेट मी नो इन द कमेंट्स.